What's up, everybody? In today's video, you are going to learn how to go from novice to machine learning expert. Let's get started. So this video is motivated by a series of questions I've gotten from viewers in recent weeks. And the questions are to the effect of, hey, how is it that you do this? And how, more importantly, how can I do this? Well, I'm flattered by your questions. I kind of make it look easy on camera. That's the magic of video editing. But please know that none of this is easy. I don't intend to downplay the difficulty of any of the stuff we're doing here. It is quite difficult. Don't feel bad if you feel it is difficult. You are not alone. All of us probably, unless you're a genius, all of us think that it is difficult. So don't feel bad, but I'm going to address how it is that you can become an expert in machine learning. The first thing you want to understand is that expertise is not a state. So expertise is a sliding scale. So to understand that, consider, maybe you're a college student. You probably went to college. If you're not, if you're a little bit older, at some point you probably learned from TAs. You probably had a class, say physics, or even biology or chemistry, where you had to go to a lab that had TAs that would help teach you the material. Now, relative to you, these TAs were experts because they'd already gone through the undergraduate experience and probably had at least a year of graduate studies under their belt, so they knew the material quite well. However, they were, dwarfed in knowledge by the professor, and indeed, even if you go to become a professor, one intermediate step is a postdoc, where you're more expert than a graduate student, but not as expert as a professor, at least hopefully. And then, of course, when you become a professor, you start out as an associate or an assistant professor, and then you gradually gain expertise as you go from assistant to associate to full tenured professor. So expertise is a sliding scale. It is because learning is a lifelong process, and because information is constantly evolving. We get more and more better techniques as time goes on. So the state of the field is constantly in flux. It's always improving. And so people always, if they want to stay on top of their game, at least have to keep learning, keep growing, and keep moving up that ladder of expertise. So don't feel bad if you think that you don't know much. None of us really know much in the grand scheme of things. We're all on a process of learning. Now, that doesn't mean there aren't levels to it. So I have a framework for thinking about it. I've never really heard anybody put it this way. So it's not some, what I'm about to describe is not some universally accepted thing. It's just kind of how I think of the problem. So don't go quoting it thinking people are going to know what you're talking about. But the way I think about it is that there are 4 distinct levels of expertise. So there is the novice phase, the technician phase, the craftsman phase, and the pioneer phase. So most people exist on this spectrum of novice to craftsman, and there's only a handful of pioneers because for various reasons. Not many people have the intellect, not many people have the drive, the life circumstances, etc., etc. So what distinguishes these phases? So the novice is characterized by their inability to finish a project without looking up significant portions of the material on the internet or in books, if you're old school. Books are great, I'll get to that later, but either way, you have to look up significant portions of the material to be able to complete the project. So what this means in practical terms is maybe you're tripping over syntax, if you are, and just to be clear, you could be an expert at, say, C and C++, but then coming to Python, you're a novice at Python, and you're kind of starting all over. You will learn faster than someone who is coming at it completely new, but it doesn't buy you access to the next phase. You're still going to be tripping up over the syntax of Python, for instance, or if you're coming from a different field where you're an expert programmer, if you're coming from systems control into deep learning, then you're still going to, be a novice when you start in deep learning. So it is it's not something where expertise in one field buys you an extra step on the ladder in learning a new topic. So the novice is characterized by their inability to finish significant portions of the code without assistance either from humans or the internet. And they are really at the phase of not knowing what they don't know and really just kind of fumbling around in the dark to try to solve things. It's also characterized by an over-reliance on tutorials, which I don't recommend, by the way. I do lots of tutorials, but I'll talk about the philosophy of how to use tutorials in your learning process in this video here in a few minutes, if you're curious about that. But don't over-rely on tutorials. That's what novices tend to do, and that keeps them in the novice phase, unfortunately. So don't do that. But they are also characterized by an inability to take complex ideas and put them together. So they can't take material from different things and plop it together to create new solutions. So that's what characterizes the difference between a a technician and a novice is that when you finally break through that barrier and you master the syntax, you master the fundamentals, and you can take different stuff and put it together into new solutions. Well, not really new solutions, but more complex solutions, let's say. So what I'm thinking of here is your ability to take different, like I'm designing a course for deep Q learning, so you need to be able to do convolutional neural networks, you need to be able to do Q learning, you need to be able to do image manipulation to handle the pre-processing of the Atari library, as well as you need to know the details of a framework. So that's several different things you have to know to be able to bring together a solution into some sort of clean code. So you have to know a lot of different stuff to bring it together into a solution to a problem. So that's the technician phase, and then from there you graduate into the craftsman phase. So the craftsmen are the people that can look at the forefront of research. They can read the research papers and implement them from the papers. So they can go from a paper into code, which, by the way, if you want to learn how to do that, be on the lookout for my upcoming course, Deep Q Learning from Paper to Code. That'll premiere on Udemy, which, hey, has a 30-day money-back guarantee, unlike some other people. So if you don't like it, hey, no loss on your part there. But I digress. The craftsman is characterized by their ability to take papers from the research literature and implement them into actual solutions. And this is a totally different skill set in and of itself. It requires a deeper expertise, and it also requires a little bit more expertise in mathematics. So one thing we didn't talk about is your level of mathematical rigor. So deep learning is a highly mathematical topic, so you really need to know math to be able to be successful in it. There's no way around that. Exactly how much mathematics you need is up for debate and is really going to depend on what you are studying or what you want to specialize in. But regardless, you need to know mathematics, calculus, linear algebra, things like that are going to be your bread and butter. Definitely need to know them. So the spectrum of understanding of mathematics is also part of what delineates a novice and technician from a craftsman, because a craftsman knows enough mathematics to read a paper and implement it. So they also have the background experience and general overall programming experience to know how solutions are going to look beforehand. Another thing that's going to distinguish the craftsman is their ability to ask good questions. So whenever you're reading a paper, you need to understand that there are some assumptions that went into it, and you need to understand the realm of applicability of those assumptions, because they don't always apply to every situation, and if you wander outside the realm of applicability of the assumptions, then the solution is going to break. So you need to know what the edge cases are, what the limiting cases are, where the solution might fall apart. So the craftsman not only is able to implement solutions from the literature, but also to understand how complex systems play together and how they can break, because it's a very important part of software engineering is keeping things from breaking. Imagine if every time you went to Facebook it broke, then it would be a useless product, even more than it already is. But software in general relies on not breaking, and that is kind of a hallmark of a craftsman, is that they can write code that doesn't break easily. All code can be broken, but it's the set of conditions under which it can be broken that dictate the quality of the code. And so next on the spectrum, you have the pioneers. Now, of course, the pioneers are the big names we all know. Jan LeCun obviously won the Turing Award for his work with convolutional neural networks. Obviously a big name in the industry. Bengio, Goodfellow, David Silver, all these guys are what we would consider to be pioneers in the field, and for good reason. They're all super smart. They all are coming up with new ideas for us to follow and to create new solutions. They're producing the literature that the craftsmen implement into new solutions. So how does one achieve that level? I don't know. I'm not there. I don't pretend to speak on things that I don't know about. I have some thoughts on how it probably starts, and one common thread amongst them is an academic background, not because the paper you receive is magical, but because the level of mathematical rigor you have to endure in a university setting is more conducive to generating the type of ideas, the type of frameworks for generating new thoughts, new ideas, new directions in research. Other thing that matters is the quality of the questions they ask. Einstein is a classic example. His simple question for generating the theory of special relativity is, what happens if you try to catch up to a beam of light? Now, it seems like from a Galilean perspective, it seems like a totally trivial thing. As you speed up, the light beam should slow down relative to you, but it turns out it's the exact opposite. The light beam always goes at the same speed, and time and space conspire to make that a reality because the laws of physics have to be invariant for all inertial observers. there's your relativity lesson for the day, your physics lesson for the day. But that simple question led to a very, very profound understanding in physics, and indeed a whole revolution that has been tested and tested 1,000 times. You know, your GPS works only because relativity and special relativity are true, or sorry, special and general relativity are true. But it's all generated by a very simple question. So probably one of the defining characteristics of a pioneer is the quality of the questions they ask, as well as the level of mathematical mastery they have attained. So, okay, so that is the series of classifications that kind of demonstrate how I think of expertise. You know, please feel free to expand or totally rearrange these concepts as you wish. It's just a mental framework I have for thinking about my own progress relative to where I want to be. So how does one progress? So the simplest thing to do to get started, if you're watching this channel, you probably already started, so whatever you did probably worked for you. But let's go ahead and take it from the perspective of someone who is just totally new, someone just seeing me for the first time, wanting to get started in deep learning, machine learning, AI. How is it that they can get started? So the first thing you have to do is to get started with programming. You have to get started with deep learning. So if you don't know how to program, if you aren't a lifelong coder, that's not a problem. You know, it certainly helps to have a deep track record of programming experience. It's obviously can't hurt you, but it's not a prerequisite by any means. And you never know, you could start in your 30s and discover you were a natural talent for it, and hey, then you know you just missed 20 years of pleasure from coding. You know, no big deal, right? So don't let the fact that you haven't started yet be a barrier to starting now. So just get started, see where the chips fall, and get in motion. That's the most important thing. So get started programming and get started learning about deep learning. So I did a video earlier on how to learn AI for free. There are two really great resources on the web. There is the Stanford course by Andrew Ng, taught through Coursera, and this is how I got my start. One downside to this is that it is taught in MATLAB, which really isn't all that applicable to the real world, but nonetheless, the coverage of the foundational topics, the level of mathematical rigor is sufficient to get you started on the path of quickly ascending from novice all the way up to craftsman within a period of just a couple to a few years. So it is a great learning tool, great way to get started. I can't recommend it enough. The lectures are a little dry, you know, it makes a fun drinking game. Take a shot every time Andrew Ng says concretely, and you'll probably be blacked out by the end of the first lesson. But nonetheless, it is a great course, highly recommend it. Another option is fast.ai. Now, I have mixed feelings about this. It is great for just getting started because it kind of inverts the learning process. Most people learn in the traditional sense of starting with theory and then moving on to code and application. Fast.ai flips it and starts you out with application right away, and then teaches you a little bit of the fundamentals later. I'm not a huge fan of doing it that way. I understand the logic behind it, and if it works for you, it works for you. That's great. This is all my subjective opinion. You know, a lot of people have success with it, so it's good, right? It's just not my preference. But it also one other thing it adds that I don't like, and I think is objectively bad, is that they have their own framework in which they code their solutions. So Fast.ai has its own library built on top of PyTorch. So at that point, you have abstractions on top of abstractions, and I don't like this. This is objectively bad because abstractions leak. You can Google that, leaky abstractions. You get problems due to the assumptions built into those abstractions that you can't easily figure out where they're coming from at the very worst. And at the best, you're relying on somebody else's code, which is kind of a double-edged sword, right? You know, it makes it easier to get started, but it makes it harder to grow as a deep learning researcher. So, you know, get started with it if it floats your boat, but always keep in mind that you shouldn't be too reliant on their library because, you know, who knows, if it breaks, then your skill set breaks. So don't get over-reliant on it. You know, PyTorch is a significant enough abstraction in and of itself. Once you've moved on from video courses, I think it's time to move on to books. So the video courses will get you through the novice phase, where you can kind of muddle your way through learning how to solve basic problems. You know how to do basic classifiers, convolutional neural networks, stuff like that. But from there, you need to move on to books. And the reason books are still important in 2019 is that the density of information is much higher in a book. And you can, the author has to be much more precise in a book because you edit it, and it's much easier to edit a text format than it is a video. With a video, you kind of got to go back splice things together. Hope the flow doesn't sound too bad. I have direct experience with this, so it's much easier to edit the written word than the spoken word. So books tend to be much more precise, and the density of information is much, much higher. So you're going to learn the fundamentals in a much deeper way. They can touch on mathematics more deeply, and so you're going to really expand your skill set. So let me show you one book that I used to learn at the very beginning. This is Python Machine Learning by Sebastian Raschke. This is the old edition. It doesn't really use a deep learning framework. I believe the newest version uses TensorFlow. So that book's a little bit out of date, but the newest version is obviously up to date. It's a great textbook. I like the way he wrote it. It's relatively clear. It covers a broad array of topics. It's pretty complete, and it has a pretty significant wealth of exercises in it to get you started to become a high-level technician or early-level craftsman. So after the books, then you need to start thinking about the mathematics. Now, you may want to do this in tandem with the coding and the video courses and stuff like that, or you may just want to put it off. It's up to you. So my background is in physics. I have a PhD in physics, so I did a ton of mathematics in my 20s. So I know I don't know all about it, but I know enough of it to be dangerous in deep learning. So if you want to achieve the craftsman level, if you want to move from novice to technician to craftsman, then you certainly have to know mathematics. It is unavoidable, and that is because when you go to implement papers, they're written in the language of mathematics most of the time. There are proofs that you should be able to follow. There are equations that you have to be able to implement and understand the limits of applicability of. So you're really going to need a strong mathematical background. So for that, I would almost certainly recommend something like MIT OpenCourseWare, where they put up courses online, lectures, notes, assignments, and in some cases solutions. So things like linear algebra, vector calculus are going to be really the two places to start learning. Once you've mastered those, then you're pretty good to go. But you definitely need mathematical expertise. So don't neglect that. That's assuming you want to achieve the level of craftsman and beyond. You definitely need mathematical rigor. Focus on mathematics and understand one thing. Now, to take a shot at another YouTuber here, Siraj likes to make videos, learn X in Y number of weeks. Now, this piqued my interest when he made a video on learn physics in 10 weeks. Having a PhD in physics, I can tell you that's absolutely impossible. You can't learn even a single tip of an iceberg in 10 weeks. You can learn, let's say, algebraic applications of Newton's laws in 10 weeks, but that's not physics. That's just barely even scratching the surface, right? And he doesn't do this to be disingenuous. I don't think it's anything, any malintent on his part. I think it's just hype to get people going and to get people moving, right? Because overcoming people's inertia is a difficult thing to do. And so he says, hey, it's not as hard as you think. Go ahead and get started. When you get started, once you get in motion, it's easier to stay in motion than it is to start moving. So, I don't think it's not an attack on his character. It's just, it's kind of clickbait. But I understand the reason he does it. But understand that learning mathematics, learning machine learning, deep learning, you're not going to do it in a matter of weeks. It's going to take years. And years are going to pass anyway. You're going to be a couple years older in 2 years regardless. The only thing you have to say is, will I be better at something in that 2 years, or am I going to be the same as I am today? And so I firmly believe you should be better in 2 years than you were 2 years ago, or now, right? Let's say. So go ahead and start learning. Understand that it's going to take time to learn this stuff, but the time's going to pass anyway. You may as well fill it learning something useful, something fulfilling, something cool. So be prepared to spend the time to learn the mathematics and to achieve the level of mastery to be a good craftsman, to be able to read papers and implement them on your own, which brings me to what I consider to be the defining characteristic of the craftsman is starting to read papers. So I have direct experience with this now because I am developing my own course, Deep Q Learning from Paper to Code, where I had previously followed other people's blog articles, which is kind of a double-edged sword. It's useful to get started, but not so useful for deep understanding. But I want to really teach people how to read papers because I think that's the defining characteristic of a craftsman. Someone that can implement new ideas that there aren't too many tutorials on because it's brand new stuff. You can pick one day a paper on the archive, spend a couple weeks going over it, really understanding it, really implementing it, getting a solid solution that you can put up on your GitHub and be one of the first people, and then write a blog article on that to be, to get your exposure for yourself, right? So if you want to learn how to do that, be sure to be on the lookout for my course, Deep Q Learning from Paper to Code. That'll drop in a couple weeks on Udemy with a 30-day money-back guarantee. Unlike some people, Udemy protects the students. And is at a reasonable price point. It'll be like $10 per subscriber, something like that. So not too much out of your pocket. If you don't like it, you can get your money back. No big deal. But that is the defining characteristic of the craftsman: the ability to take a paper and turn it into functional code. Other thing I want to point out, and something I see otherwise good coders making mistakes on, are some other things that define a craftsman. There are certain, how to describe it, certain skills that aren't directly related to your understanding of deep learning, but do show a mature understanding of good coding practices. So the biggest mistake I see people make is comments. So comments should not tell you what the code does. A comment should never describe the functionality of the code. The functionality of the code should be obvious from the names of the variables, names of the functions, and names of the classes and objects. I should be able to read it, particularly in Python. In other languages, the syntax is more obscure, let's say C++, for instance, or C. But in Python in particular, which reads pretty much like English, I should know exactly what the code is doing just by reading it. It should tell me what it is doing based on the names of the things involved. The comments should tell me the context around what is going on. Why is this being done? What is the historical reason for doing it one way over another? Because there's often more than one way to do something. So why is it done this way? Well, it's done this way because we tried it the other way and it broke for XYZ reasons. So that is a good comment. It gives you context, historical understanding, and really stuff that you can't get by reading the code on its own. Good code should always speak for itself. Other things I see people make mistakes in is variable naming. This relates to the first point, but you should be very careful in the choice of names. That's one of my other complaints about Fast.ai, is that they use 2 or 3 letter variable names in their code, which I don't get. Like, they, instead of saying batch_size, it says BS. Well, I mean, what is BS? It could be an array of B's for all I know, right? It doesn't make any sense. It's poor, very, very poor practice. Jeremy Howard's a great guy, great asset to the community, but don't model his way of writing code. Don't use 2-letter variable names. Use full words separated by either camel case or underscores. Doesn't matter which. Just stick with whatever your convention is. But either way, the variable name should tell you what they are, what they do. Noun verb format is probably best. And stick to the PEP 8 style guides. Don't have run-on. Don't have your lines of code go beyond 80 some odd characters, 80 characters, I think, because it's bad. It's not readable, and it kind of shows that you don't care about quality. And if I'm reading your code and I see a big giant line of stuff, I'm going to get irritated, as well other people. I don't matter. I'm irrelevant to your life. But if you are applying to a job and someone sees that you have giant run-on lines of code, they may say, this person isn't a very skilled programmer. Likewise, if they see that you have variable names X, Y, and Z, stuff like that. So that is also a hallmark of a craftsman, is writing good quality code. Always be striving for that. And that's something you can do even as a novice. And one thing that will help you become a much better programmer much more quickly, because it makes the code more clear. It helps clarify your thinking. It allows you to focus on what really matters, which is, understanding deep learning. And as far as the pioneer stuff, there are some common threads. They go to universities. I can't really speak on that because I'm not one, and I don't really like to speak on things I don't know about. I can speculate, but it's really pointless. If you're watching my channel, no pioneers are watching my channel. I hold no delusions about that. I'm not that big, so it doesn't really matter. So don't worry about those guys. Worry about becoming a craftsman. Worry about advancing your career as quickly and as effectively as possible. If you found this video helpful, make sure to share, comment, subscribe, and hey, I know only 14% of you are getting my notifications, so make sure to hit that bell icon, and I will see you in the next video.